I did not know it was going to play for that long and with audio. So anyway, welcome. I just clicked the button. Welcome. Welcome everybody to Speakeasy JS. This week we have two talks. We're going to have a talk by Dominic Tarr about the programming language that he's been working on, which is called Acid, and he's going to tell us all about it. And we also have another talk from John Hiesey about his language, Xylem, and he's also going to tell us all about it. And it sounds things that these are both pretty early stage, so it should be pretty exciting to hear all about it. And we're also joined by a few panelists who have been at the other Speakeasy JS events earlier. So we have Mikola. Say hi, Mikola.
Hello.
We have Michael. Michael, is your audio working? Okay, hi, Michael. And then we have Paul.
Howdy.
Cool. All right. So we're going to go ahead and get started with Dominic's talk first. So Dominic, you're up. Go ahead and take it away.
Hi, everyone. I'm Dominic. I'm calling from a sailboat that I live on here in Auckland. They requested me to do this. This is the view. It's not the best weather today, but we're back in the city right now. But yeah, so set the scene. A few months ago, I was sailing this boat around the North Island of New Zealand, which is quite a long way. And at the end, then meanwhile, while I was doing that, there was this global pandemic. And I get back to the top of the North Island, and New Zealand's in lockdown. And I'm like, well, this is perfect time to start like a project that's like, you know, completely useless and unrelated to like anything, and it's just a project for like my own interest. And I'd kind of had some interest in like WebAssembly and making that compiled to that worked on WebAssembly before. I'd previously tried to make I'll implement a Lisp in WebAssembly, just handwritten in the Lisp in the WebAssembly text format, because it looks like there's a Lisp version of it. That turned out to be actually much harder than I thought, but I spent a week doing that. Stopped for this time. I was like, okay, I'm going to start again and do it again. And I kind of wanted, because I've been doing JavaScript for like a decade, but as working at Scuttlebutt, I got more into like level JavaScript. Like I was basically writing C code, but in JavaScript, but like writing data structures and protocols that work directly on binary buffers, where I'm like thinking about like exactly where are the bytes and making data structures and stuff on top of buffers without having any of the high level features that C gives you, like the concept of like structs or pointers and that sort of stuff. And occasionally I've dabbled in actually writing C, but I just can't stand the fucking compiler, toolchain, make, and that sort of stuff. It just seems like C doesn't have a module system. It's just total mess. And my general personality is like, when I see like, oh, there's a problem, it's just like instead of like trying to learn how that thing works, if something's obviously stupid, let's just start again from scratch. So I was like, I'll just make a compiled language from scratch. And I wanted it to be something that's like low level, like a low level system programming language like C, but I don't want to type all that extra code, so I wanted some like high level stuff. I was like, what could I have like a Lisp, like Lisp macros, but like Lisp macros at compile time, but produce like C at the output. So like you have all that dynamic stuff, but only during the compiler, and the compiler is essentially like you're building a modular, like with macros, you build a modular compiler, and but by the time it's actually running, it's like fully static and fast, like C. So I just started experimenting with this, and if anyone has tried, you can whip up a Lisp for very little effort. Like you could have Lisp, you can write a Lisp interpreter in like a couple of hours, or less. You could probably live code it if you practiced a bit. Like it's totally simple. Then making it so anyway, I started exploring this, and I implemented macros, and I found actually I don't like Lisp macros. Like they are like functions are really nice. A function is simple, takes some arguments, it does something, computes a value, or maybe it does side effects, and then it returns a value. The way a function's called is the same every time. But then a macro is like, it looks like a function, but it's not a function, and it can do things that functions can't do. So a function, for example, a macro, for example, the arguments that it takes aren't like if you pass it a variable, it doesn't get the value inside that variable. It gets the code, that expression of the variable. So if you pass it an expression, it doesn't get the value that expression evaluates to. It gets the whole expression. So it gets the code, and then it does something internally, and then outputs some code, and it can output. So you can use this to basically like a function, where you call the macro and it inserts the code that would be inside of that function. So it looks the same as calling a function if you use it like that. But you can also do other things where you could use it to create new variables, or to modify a variable that's passed to it, which you can't do with a function unless you can do a pass by reference. So a function has these nice simple properties and simple edges, but macros, you can do a whole bunch of shit that you can't do. And that when you look at the code, it's really not obvious that that's what the code does. So when you're reading the code, it looks like it's a function, but it turns out it's a macro. And then that macro, you look at the code for that macro, and it's crazy. It like has all these things like that quoting and unquoting, and then you try to make a recursive macro, and it's like, this was so hard to debug, and it's just like, this isn't simple, and so it's like, these are terrible. Like I don't like macros. But then I had an idea. I was like, why can't macros just be like closures? Why can't they just be functions? So I started thinking about this. Like, what if I just you wrote a function? So when you call a function, it just inlined the code of that into the code that you called it from. So it just like flattened everything instead of making like so if you make lots of small function calls, it just compiles to code where those function calls aren't function calls. They're just in the function that called them. So it just inlines all the code, so it goes faster and saves the jumps. And then if you want to have, like, often I use like higher order functions where I have a function that returns a function, and you call the functions like at startup time. You get these functions, the particular thing, and then that gets aligned into your code. So you still have this dynamic thing, but closures are like slower in JavaScript because of how they they do memory and access and that sort of stuff.
So Dominic, could I interrupt you to ask a question really quick?
Please do.
Yeah, I'm wondering, is this like going to be, is your idea to like expose to the user the macros, or like to just let them use functions and then like turn them into something like like the equivalent of a macro under the hood? Do you want them to have that like power?
There's the now thing. There's only functions, but on the inside they become like closures.
Okay.
They become macros. So it feels like functions, but acts like macros.
Cool.
Is that like the case with everything, or do you have some kind of premise of a function in the system? Right? Like,
yes.
Do you just everything's inline?
Yes. Sorry, no, not everything is inlined. Not everything can be inlined because of recursion. You can't inline recursion unless you have your own stack. But can you see my screen?
Yeah, we got it up
example
now.
What I mean. So here's a function called EQ. It returns a function that checks equality to something. So pass in some x. It returns a function that takes an argument that then checks the thing. Then you might go like, and then later, so you can create a thing that will check if something is equal to bar.baz. Later you pass it a variable and it returns true or false. So if you did this in JavaScript, you'd get this function and then it would call the function goes off to another place, and that function has closure scope, which is more expensive than like a prototype object, and it gets the X from that and checks the Y and stuff like that. But in this inlining scheme, this call to E, the string foo, becomes this expression. So it sets the variable, it sets the arguments of the expression to the arguments you passed in. So it sets X to bar.baz. So actually that's not right. That would actually happen higher above in the scope, because at the time that you created the thing, that would happen there. That would be inserted there. Then x.e.foo becomes assigns y to foo, and then does the thing without doing any function calls. So it becomes as expensive as local variables. And so this was just the simplest way to like inline it inlines the expressions, but this will has exactly the same output. And there's a few details I'm skipping over here. Like when you ever do inlining, it traverses the thing and it makes sure that all all variables are unique. So these get numbers appended to, so that they're not the same as any other place you call the function, so that it doesn't need to check closure scopes. It just like makes the closures. It works the same as if the closure scope was shadowed and stuff correctly, but doesn't it doesn't actually know about the closure scopes anymore. And it comes out just as it will come out basically the same as if it was handwritten imperative code. And then later, there would be another pass where you eliminate extra variables, so you can slim it down. And basically, the method I figured out was just like build the compiler and a bunch of transforms where each transform isn't too complicated, and gets it more towards the state that you want to have in the output. So I got to this level of like this idea, and I was working on that I was working on that a while, but then the lockdown ended, the city, and it just went on the back. I kind of got stuck, went on the back burner for a couple of months, and then I had eventually I had an idea that I'd taken the wrong approach. I shouldn't have tried to get it compiling to WebAssembly as immediately as I did. Better if I started out and compiled to JavaScript language, but compiled to it of Java that I knew would be easy to run in WASM, then to implement itself faster, because it was rather similar semantics to JavaScript, except but have function variables and if etc. Function calls, and then is and objects, but simpler for compiling. Arrays are always fixed size, and objects can't add keys to it. So JavaScript is kind of complicated, is kind of weird in that, like in JavaScript you have hash tables. So the objects in JavaScript. Originally, in the 10-day JavaScript hack that we had JavaScript started out, they were obviously hash tables. And then later, when they set about to optimize JavaScript, they figured out a way to make them into structs. But so struct, if you're not familiar, is like you get some memory, and then you put the fields in here, and it's a fixed size, and you know that each field is like a fixed step. It's like this position in the block of memory, there's this variable, or a pointer to something like that. In JavaScript, it starts off as that, and then as you add things, comes different types, and then if you do something else, it magically just becomes a hash table. And having it do all of these things internally magically is like, it's too complicated. And it's basically like, it can be fast or it can be slow, and how you use it depends on, it goes slow, and it would be better to just make it do one thing, and then you have an explicit thing to use a few keys on. So then I was like, it was time to go sailing again and get away from the city. And then I got nice island, and then they have another lockdown. So I'm like, this is a sign. Time to restart from scratch. And in the meantime, I'd also decided I didn't like the Lisp syntax. Like it's quite cluttered, because it's like all the parentheses that all look the same. I think the way that my brain works, I prefer like the name, like processing names and words is slower than processing shapes.
Is anyone else struggling to hear the audio right now? I think it's his boat internet.
Syntax with different types of brackets, different types of brackets, things like that makes more works better for me than having words for everything, because you know, they look. So, sorry, I might be able to show what this looks like.
So Dominic, we were struggling to hear you there for like the last minute. I think it might be the internet. So I turned off your screen share.
Okay, my computer's a bit stuck. Oh, sorry, is that?
No, I mean, we couldn't hear you for a little bit there, yeah. Yeah, I think you can keep going for another couple minutes, and then we'll maybe switch to questions. I think we gotta, if the signal doesn't improve, we might just need to move on. Yeah, I think this isn't working.
Okay,
I think what we need to do,
screen sharing is makes my computer go really slow.
Okay, maybe try disabling that, and then we'll keep going.
Yeah. Just when I so I just turn it off. So yeah, so I started over again. This time it's like inlining everything. That works pretty well, but I also figured out the limitations. So like, if you can't have a recursive thing, then you can't just inline it because it has to call back into itself. So those things need to be rolled out. And then so there's some things you can't handle. So the next thing I'm going to do is just take the closures and then transform them into flat functions. So there's one layer of functions, and basically to closures and then turn them into like object-oriented style. So there's no nested functions. And basically the way you do this is you take a function, and then all of the variables defined in that function become properties of the object. And then when you define another function inside of that function, a nested function, it has its own properties, and it has a pointer back to the parent scope. So it has like a parent thing, and then you just call that function. So you get an object that has one method on it called execute or something, and then when you call the nested scope or return it, you return this object instead. And when you call the function on that, you call the object.execute. And then you could actually take this, take nested closure code, and then turn it into flat object code. And then I think actually even as JavaScript, this would probably go faster because somehow objects are more object than closures. So I don't think this is actually a very expensive transformation to do. So you could actually just compile JavaScript to JavaScript with this sort of approach and make it go fast. Yeah. And then you get also something that is closer to what the JavaScript, what the WASM semantics are like. How are we doing for time? Because I could keep on going, or I could.
We actually have to probably move to questions now, and then maybe do like one question and
sure.
Move on. Is there anything you wanted to finish off with, though?
Making a language is fun. Xylem is definitely good. I think we need self-hosted WASM tools where everything you can do everything inside WebAssembly, and I think although WebAssembly can support like legacy shit like C and that sort of stuff, that just stuff will bring so much baggage that to make something really nice, really elegant, just like in WASM for WASM. That's what I'm trying to do.
Uh-huh. Makes sense. Does anyone on the panel have a question? Did anything pop to mind? We only have time for maybe one.
Just one, so it has to be good.
Yeah, exactly.
I guess I'll ask this.
Oh, go ahead.
Oh, well, yeah, I was going to ask, I get the sense that you're trying to tailor ACID to be a nice fit with WASM. And like, I'm curious, like, to what degree you're trying to stay close to the semantics of the WASM VM and the opcodes that it includes versus creating a language that actually departs from it significantly. Is that a goal that you're trying to get, to make it almost feel like you're working directly with the like textual representation of the tokens? Or are you looking for something higher level than that?
Yeah, it's definitely higher level than WASM, because the actual WASM engine is quite low level. It is a bit below the JVM in terms of what you get. So you get functions and like a stack. So you have function calls, but the arguments can only be numbers, floats, or integers. And then you have linear memory. So you have got to manage your own memory, and you can pass the numbers but interpret them as references to that memory. So it's like not really it's too low level. It's lower than like C even. It's too low level to really be productive, but it's also higher than what you get in machine code, where you have registers and you can just jump to arbitrary points. You don't have arbitrary jumps. So it's a little bit lower than the JVM, where you have that stuff that have objects and the memory is structured, and ACID is actually going to have its own, it's going to have an own memory model. So I'm also going to be able to compile it to the JVM because that's actually a pretty sensible model to have. I think giving direct access to raw memory is too many ways to shoot yourself in the foot. But if they did that, if WASM was that out of the box, then it would be too inflexible as a compile target. So, yeah, my idea really was to find like an interpreter that is like the reference implementation. This describes what the language does, and then figure out ways to optimize it without changing the semantics. So really the goal is simple, make it as simple as possible. So I want you to be able to read all of the code and understand 100% how the language works, but still be able to make a powerful language.
Yeah.
Great. Well, thanks for sharing that with us, Dominic.
Thanks for having me.
Yeah, unfortunately, we got to move on because we have another amazing talk coming up from John. So John's going to be talking about Xylem, and take it away, John. It's all yours.
Cool. So let me share my screen. Let's see.
Cool.
Can everyone see the slide?
Yep.
Mm-hmm. Cool. So this is a project that I've been working on for a very long time, as very much like a sort of kind of research project. Since I started learning programming way back when I was fairly young. I started working with microcontrollers, programming PIC microcontrollers in assembly, and that was after I'd already done some hardware work. So I was used to working with like analog and digital chips, where everything is sort of inherently parallel and you just have various signals flowing through. And I thought, wouldn't it be really nice if you could do that in code much more easily, sort of like how you think about hardware or spreadsheets, where you have data that flows through your program from some inputs eventually to some outputs. And I spent a lot of time thinking about this back when I was in college studying computer science, and I realized that this was a really hard problem to do in a like general purpose programming way. And this has kind of turned into a bit of an odyssey where I realized that I had to solve a lot of other problems first. So it's very much unfinished, but part of it works. So what I'm trying to do is kind of reimagine programming. And one of the sort of big intermediate goals I came to along the way to this, make everything functional and have data that flows through your program is I realized how much you can gain from pure functions and pure computations that don't have side effects. In other words, can I write a language that's actually usable for, real world things where you're interacting with the world and reading files, writing files, talking to the network, that kind of thing, but have it also possible to interpret it in a pure way so you can get a lot of those benefits as well. So this is sort of trying to smash that together. Haskell kind of tried to do this with the IO monad, but I think that didn't really work very well in practice from my own experience. So the goal is to try to fit all these ideas together into one piece. And what I mean by semi-pure will come up. You'll see what I mean. So pure would mean that any function just computes a result and does nothing else. And my language is not quite pure, but it's close. You'll see. So the solution to this, these are huge goals. So how do we get all this to work together without getting completely overwhelmed, which I have already anyway. So, but the solution that I came up with is a little bit like what we do in networking, where we split things up into a stack. So traditionally, your language would be one piece, but instead I've broken it into two. There's a base language that's very minimal, almost purely functional, sort of lambda calculus-ish. I'll give some examples in a few slides. And then on top of that, you build a whole sort of another meta layer that lets you do all the fancy stuff. And the reason this is nice is neither piece has to be quite as complicated as it would be otherwise. So the sort of goal of the second layer is to be a little bit like Smalltalk, very traditional, classic object-oriented programming in a sort of pure sense. Pure not as in, pure functions, but pure as in the essence of what Smalltalk was trying to be, which is you have objects and you have messages that get passed, and not thinking about this too much from an implementation perspective. So this is very different from Dominic's language. This is not going to be fast. I guarantee it. This is very much a sort of greenfield experiment, and it's not. Performance is definitely a downside. Okay, so layer one, the base language. So it's a minimal, dynamically typed, object-oriented language with some odd design choices. So I say odd design choices mostly because of what's left out. So this is a function definition, It's essentially a factorial function, so backslash is your lambda. So it takes 2 arguments, and then I think you can imagine what this means if n is less than, it's your traditional recursive factorial. One thing you'll notice is that I'm passing, this recursive function I'm passing the function to itself. And the reason I do this, and the reason you have to do this in this design, is that all of your data and all of your functions are acyclic. So there's no way to create a circular reference in your data. So a function can't, I couldn't write factorial that just takes one variable because the function name isn't in scope inside. So I'm kind of forced to use this workaround. And this is not how you'd actually write something, as you'll see later. If you have the second layer, there's a better way to do it. But if you really wanted to use it as just the first layer as a traditional functional language, you could write something like this. So we define factorial by passing factrect to itself. And since it supports currying, which means that I can pass one argument at a time, it's very different from JavaScript. In JavaScript, you can check arguments.length and see how many arguments you get. This is very different. If I pass, one argument to this function, that returns another function that takes the rest of the arguments. So fact is now a function that takes one argument. And if I pass 5 in, I get 120 out. Objects. So this is kind of like JavaScript, except I have this special object constructor. The curly braces are just more like a dictionary and a dict in Python. They're key value. It's just a hash map. So object actually converts that into something you can call methods on. And you can define these as lambda functions. Use dot for methods and arrow for fields. And you'll also notice, so result1 equals an object dot a method. So it'll call this, automatically passes self, sort of like this in JavaScript, except it's explicit. So if I call a method 3, it'll multiply 6 by 3. And you'll also notice I can call a method without any arguments. And this is actually a method call. This is not just getting reference to a method. Because of currying, what really is going on here is object.method really means call this method with self equal to an object. So this actually calls it with one argument. This calls another method with one argument. This calls a method with 2 arguments. There's the implicit self and then another argument. So that's kind of boring, but let's get to the interesting part. So how do we actually do things that are kind of imperative? This is not too useful so far. This just lets you calculate things. I can write, I can calculate factorial, I can do some multiplication. Doesn't let me interact with the real world. So how do I do that? So I have this special feature called trap. And what this actually does is this will call f. So f is this function here. And this will call trap, or will call f with a special argument. And you can think of this is kind of like it's essentially like a generator, except this argument that gets passed in is what actually is like yield. So what this says is when I call f.trap, it'll start executing function f with this special argument called a handle. Whenever you call the handle, it will pause executing F and return this object that says result null. It's sort of like finished, not finished generator. It'll pass in an argument and a continuation. And when you call the continuation, that's like resuming your generator to get the next result. So you can treat it like a generator. One thing to keep in mind is, like pretty much everything here, from the outside, this is purely functional. So I can call the same continuation twice with two different values, and it's like the computation branches. It copies the state every time you call the continuation. So that's completely different from a JavaScript generator. In JavaScript, if you have a generator, every time you resume the generator, it's changing the state of that generator. But here it returns a different continuation each time. So you can keep calling. You can essentially like have the computation. You can run the function part way, and then you can finish it up in two different ways. It's a little bit like fork with processes. So fork takes one process on a Unix system and splits it into two. So you can just fork any function in the middle and get two different branches. And then, these will give the same result no matter what order I call them in. Now, those of you who, especially Dominic, are probably thinking this is not going to be fast, and it's not. Performance is definitely a problem, but I have a lot of tricks. This part is mostly working in my interpreter that I have. So I've written an interpreter in JavaScript for this language, and this mostly works. And this feature so far does essentially work, although I think it's a little bit buggy. Yeah, so you can think of it as a resumable exception also. Like, instead of get input, you can think of this a little bit like throw. You can think of this a little bit like throw, and this, calling f.trap is a little bit like try catch. So it can either run all the way through to the end and return a result. Oh, I should mention that the last expression is the return value. So if you were thinking JavaScript, there'd be an implicit, there'd be return this value. But in my language, in Xylem, the last expression in any function is the return value. So you could emulate try catch by calling function.trap and then just calling this argument throw, and then I'd write throw something, and then you can resume from the throw just like you resume a generator. And that's how this is a little bit not like a generator, and then I could call other function, I could have this call some other function and keep passing this handle argument through, and it can go as many layers through the stack as you want with no special syntax. In JavaScript, you need to write, you have to have, you have to explicitly say that something's a generator, and you have to use yield. There's special syntax for it. Here, it just looks like a function call. So it's a little bit magical. The other thing is that I'm not going to get in too much because it gets very complicated, but these are actually composable. So I can have multiple of these traps nested inside of each other at once. And you can have any one can halt the execution, and then you can resume back anywhere that you stopped. So, for example, you could have one that does logging, and then you can have another one that provides some other function in your program, like interacting with the outside world. And they don't interfere with each other, which is that's really tricky. But I don't want to get into the details. Okay, so how do I write a program? These are great. This just lets me, I'm calculating some results. Okay, that's not very useful. Let me write a real program. So what does main look like? So main is a function that takes a trap, essentially, that lets you make system calls. And I'm using system calls a little bit loosely. We're not talking like Unix read, write, send, or ioctl or whatever. I'm using the term a little loosely, just mean interact with the outside world. So I can call read file or print, and a real library would probably organize this a little bit better. But the idea is this main function is like a generator that tells the operating system what to do next. So I start my program, start main. Main will essentially yield like a generator, a command to read a file, and then it will resume providing the contents back to main. So you resume main with the contents, and then it'll halt again, print the result, and then resume with no argument, and then it'll return 0, and then your program exits. So this just cats my file out to the screen, essentially. So how do you actually use this to do more interesting things? Well, what you do is you structure your program. So here's your main. And what we're going to do here is structure your program like a tree. And what the colors represent here are different types of nodes. The green nodes are containers. So they don't really, think of them sort of like directories. They don't really have any behavior of their own. They're just, they're kind of like directories, or they're a little bit like, I guess you could say they're like spans in HTML, kind of. And then inside, there's a few different kinds of nodes. I'm going to call this start. This is an imperative method. So this is something you can call. And then there's other kinds of nodes. These are essentially variables that you can read and write. So think about in a spreadsheet, just the cell that you type a number into. Like, in Excel, you just make cell A1 2 or something. That's more like this. And then this blue node here, which I'm calling a flow node, is a reactive node. Think of that like a formula in a spreadsheet. So a flow node would be, equals in Excel, for example, or Google Docs or whatever you want to use, LibreOffice, you'd write equals and then a formula. So this is showing the structure. I'm really thinking of the entire program as a tree, sort of like the DOM in the web, or a little bit like a network. And what's really going on here is there are events that flow through the edges of this node, sort of like messages flowing through network links. So there's a few kinds of messages. We have messages to call a function. So when your main program starts, main gets from the operating system or the runtime of the language a command to run the start method. And then start will send more commands. So here's a little bit of code that goes along with that diagram. So main equals make reactor. Reactor is essentially just the way you make the root node in this graph. And then we have two subnodes. We have data and start, just like in the diagram here. And data make inner node. So this is just like essentially a container that holds things, just to keep things organized. And I have a static node and another static node. These just use this make static node constructor that takes some integers. So these are basically, you can think of these as like spreadsheet cells that contain the values 2 and the values 3. And then a flow node uses this other constructor that gets past this handle called get, and this is like an Excel formula, more or less, where you can provide paths in the tree, relative paths in the tree, to the nodes you want this to be equal to. So this says it passes in this, you get this get function, and I call get a static node. So if I wanted to evaluate what this is equal to, it would be get a static node. Well, that's going to be 2 times get another static node, which is going to be 3. So this whole node essentially is equal to 6, just like if you'd defined a formula in your spreadsheet. Now we get to the imperative function down here, start, make imperative node. And here we get handle, and handle is this is similar to the idea of syscall back in this slide. I can call handle.get, that gets the value at a node. So this will calculate the value of a flow node. So as we already said, the value of this was 6, and I provide dot/data, treating, you can think of start like a file in a directory, and this is the path. Relative to this file, or this node start, you look in the same parent node, look up data, and then a flow node. So you pass in this path, you call get, this value will be 6, then I can print that out. Then I can, but what else I can do is I can set another static node to 4. Just like in Excel, you could type into, just type into the cell and change the value to 4. And now the value automatically updates. So if I call get again and I print the new value, now it'll print 8 instead of 6. And eventually, in addition to get, I'll also have subscribe. So I can subscribe to changes and say, run this handler when this changes. It's essentially a change listener. So I could say handle.subscribe a path, and then provide the the name of the method to call. So I could have my handler also, inside of main as another method down here. And there's a lot of fancy stuff you can do, but this is the basic idea. This is a whirlwind tour. So I have a very rough version of this, written in JavaScript. I have designs on paper for the rest. Not public yet, but I do want to fix that soon. It's just such a mess right now. Eventually, I want to do fancy stuff and provide a nice type system to go along with it and actually make it fast. But that's going to be another challenge. Question?
Amazing. Thanks, John. That was amazing. Yeah, let's see. Does anyone have any of the other panelists have any questions for John? And if you're watching the stream too, you can type some questions in to the chat if you want to ask John something. Dominic, go for it. You might be on mute.
I can't hear anything.
Sorry, I was on mute. Your continuations are they're actually exactly like callbacks, but with a different syntax, with an equals sign and a value. But the behavior you have where a continuation, you can call it again and it continues as if it was for that, exactly like callbacks. Callbacks do that.
Except that a callback can can like change variable state.
Ah, yes.
With this, if I call, yes, it's very similar. It is,
Yep.
I programmed with callbacks a long time in JavaScript. It is very similar, except you can, pause and resume without, your nesting of doom.
Yeah, to compiler transform.
Yes.
Do you have nested closures? Can you define functions inside of functions?
Yes, definitely.
So I have a question. Is there
Yeah.
like maybe a way for these? So these things, they're all flow-based and asynchronous. Can you run these things in some kind of distributed environment, like over a network? Or is the idea for them to like just be like a sort of UI production thing? Or is it like, what is the project for this? Is it, or the grand vision? Do you
The
see this
grand
being
vision
like, yeah.
is both. I do want it to work. Like I could define a subtree functionally as part of another subtree, and that subtree would then be rendered as a DOM, essentially, sort of like in React. But I also imagine this working over the network, as you say. So I could serialize these messages and pass them over the network, just like I can make calls between nodes in one process. So, I think it would be a mistake to say that functions are not, the semantics are not going to be the same between running in locally and across the network. Locally, it's pretty much synchronous. Across the network, it's very much not.
Well, but why not, right? I mean, if it's like an immutable language or whatever, you should be able to have the same semantics, right? Whether you execute it locally or whether you run it over, another thing. I mean, you might have to worry about failures or whatever.
Yeah.
But I wonder if like maybe you use something like an authenticated message stream, for example, like what Scuttlebutt does, right?
Sure.
You could actually make sort of co-recursive authenticated data structures using something like that. Like,
yeah.
That would be kind of a neat application. I don't know.
Definitely. No, by saying the semantics is different, all I mean is that, if I make a call across the network, I probably don't want all other updates in my local process to be blocked. So when it's running synchronously, these calls are sort of blocking in the sense that as long as nothing calls the operating system, you're guaranteed you won't be interleaved with other updates. That's probably not going to be true over the network. But yeah, you can totally you can have authenticated message streams, and you can have, the goal is to have the reactivity work over the network too. So I can say, this DOM element in your browser is ultimately functionally tied to a database entity, going all the way from the browser through the server back to the database.
Yeah.
That's the grand vision.
Sorry, I was just going to say, it looks like Dominic's Vote Internet gave out. Oh no, he is trying to rejoin right now. Cool. But I love how different your two languages are. This has been like such a contrast between the two. It's really been quite interesting to see such different goals and the different approaches. I have one question I wanted to ask you, John. I'm wondering, if I'm a user and I'm trying to write some code here, and I'm trying to figure out whether I should use a function or I should use a live updating node. Mm-hmm. How would I decide between the two? Because it seems like a live updating node is just a function that goes and gets the data from other cells or nodes in the system, and then it may be maybe it's doing some kind of caching or memoizing or something, but it's basically a function call. Is that right, or is there something else it's doing?
Yeah, that's right. If you just want to write a function that literally takes an input and always gives the same result, then for a given input, you always get the same answer, then you want a function. If you want to have something that depends on some other state elsewhere in the program, then you'd want a live updating node. So like I could write like, for example, I could write a JSON parser or something using a pure function. But if I want to have something that like calculates like the state of like the number of some type of objects in my like DOM tree or something, then you'd need a live node.
Interesting. So basically, to access the state in the object, you have to use a live updating node. You can't read nodes from functions. You have to make a live node. Okay.
Exactly. And the live nodes are built out of functions too.
Okay.
It's just there's sort of two layers. You can think of the live nodes are sort of meta functions in a sense.
Mm-hmm. Cool.
I see one question in the chat. Why is the IO monad bad? Mostly because it requires specific syntax. For example, if I wanted to add logging to my program, then I'd have to restructure all of my code to be in some sort of either the IO monad or some sort of logging monad. Here, all I'd have to do is change the way main runs and essentially pass this through to every function in my program. Like put all my functions inside of a function that has that in scope.
Super cool. Any last questions from any of the panelists? I think we maybe have time for just like one more. Anyone have a question for Dominic or John?
I have one troll question that I'm going to leave. Have you thought about making all of the events come from a blockchain?
I mean, as a troll question, I think
you don't have to think about it too hard.
I mean, that's basically you're kind of building,
Ethereum.
Yeah.
Yeah.
I mean, totally. I could see that as an application. It's not the application I'm particularly interested in.
And no one cares if it's fast. It's probably faster than what people are already doing, right?
This would probably be a much more suitable language for writing smart contracts than
Solidity.
I don't know. Whatever. Maybe. I don't know.
Oh no, we lost Dominic again.
Totally, you could do that. It actually would be a good fit.
All right.
I'm just not excited.
Expert and immediately go up a couple of pay grades. So there you go.
Nice.
It would do that well.
Okay. I actually have to run, so I don't know. Should we wrap this up?
Yeah. Let's wrap it up. All right. So we're gonna do the social happy hour part of the meetup now. So I'm gonna explain a little bit about how that works. So the way that this works is we have a platform that we're going to switch over to now called Speakeasy.co, and the way it works is you're going to get matched with a random attendee who's watching this stream right now, and you're going to get shown an icebreaker question, and then you'll have a chance to just chat. So this is like really it's one of the main reasons why you go to meetups is to talk to people and to make friends and to it's not just about the talks. Often the best stuff comes from the people that you meet and the friendships that you form. That's actually like how I met most of the speakers here at Speakeasy JS has been from meetups and conferences. So we're trying to recreate that in a virtual way right now. And I see somebody in the chat saying they have a question for Dominic. Well, good news, you can just join the happy hour and hopefully you'll get paired up with Dominic and you can ask him directly yourself. So that's the idea here. So this is the URL to go to. Just type that in to your browser, and then you'll go to there and you'll just click start, and you'll get starting to get matched up with people who are attending. So that's it. Thanks to the speakers. Thanks to Dominic. Thanks to John. Thanks to Nicola for joining, and the other panelists who had to leave early / who had their browser crash from using this conferencing app that we're using. So Michael and Paul as well. So thanks, guys. Super
Thanks for
appreciate
having
it.
us.
Yeah, totally.
Okay, bye. Thanks.
Bye.